Welcome to a two-sample t-interval example. So in this example, a study was run to estimate the difference in the average hours of work a week between CSU students and UC students. A random sample of 50 CSU students averaged 18.2 hours of work a week with a standard deviation of 8.3 hours. A random sample of 40 UC students averaged 12.5 hours of work a week with a standard deviation of 4.5 hours. Find the 95% confidence interval. So our goal, we're trying to estimate the difference in the average hours of work between CSU students and UC students. So this is an estimation question. We're doing a confidence interval, which we also have listed down here. So we're doing an interval. We're talking about average, or the mean. And we're comparing CSU students and UC students. So we have two populations. In addition to this, we have a random sample of 50 CSU students with an average of 18.2 hours of work and standard deviation of 8.3 hours. And then we have another random sample of 40 UC students, average 12.5, standard deviation of 4.5. So the sentence highlighted in purple is one sample. The sentence highlighted in pink, we're looking at another sample. And then the confidence level we're looking at is 95%. So just in terms of our usual setup, the very first thing we need to do is understand the problem. So we figured out that we are working with the mean, doing an interval, and we're looking at two populations. And then for our CSU students, we have a random sample drawn from the entire population. And then we are told that that sample had 50 students. So I'm just going to scroll up briefly so my picture is not blocking this. So the random sample of CSU students was 50 CSU students. So that's n equals 50. Average of 18.2. So that's x bar is 18.2. Standard deviation of 8.3. So that'll be S. That's our sample standard deviation. I'm going to take CSU students to be population 1. So we'll label N1, sample size of population 1 or CSU students is 50. X bar 1 is 18.2. And S1 was 8.3. So just a note here that this is sample standard deviation. So that tells us that we should use the t distribution. All right, so that was population 1. Population 2 would be UC students. This sample was also random and drawn from the whole population. If I remember correctly, the sample size of our UC students was 40. X2 bar is 12.5 and S2 is 4.5. So just checking that briefly. In the sentence highlighted in pink, we had a sample of 40 UC students. That's our sample size N2. Averaged 12.5, that's X2 bar, and standard deviation of 4.5, that's S. The other piece of information we have is that we're doing 95% confidence as the question requests. All right, from here, confidence intervals, the very next thing is simply to justify. So our justification, we need a good sampling technique for both samples. So that's random, which we have, and drawn from the entire population. In addition to that, we need our normality conditions. For the sampling distribution. We're hoping that those are met. So we are here working with the difference in sample means, so X1 bar minus X2 bar distribution. And the requirement for this is the same as the requirement for the X bar distribution, except for it has to hold for both samples. So again, we just need either the population data to be normal, which we don't know, or we just need each sample to be at least 30. So each sample was size 30 or larger. So we meet our condition for normality. So we can run the confidence interval. Because both samples came from a good sampling technique. And the conditions for normality of the x1 bar minus x2 bar distribution are met. We can add a sentence justifying the t distribution if we like. So we will be using the t distribution. Since we only know sample standard deviation. From here, it's mostly calculations, and we are going to let Desmos do that work for us. So this is steps 3 and 4 for confidence intervals. So understanding the sampling distribution as well as finding the interval. So steps 3 and 4. So this was understanding the sampling distribution. And finding the interval. We will use Desmos. I have a particular link up at the beginning of this problem. So if we follow that link, then we can enter in our information. So our population 1 sample size was 50. The sample mean was 18.2. And the sample standard deviation was 8.3. And then for population 2, we had a sample size of 40, a mean of 12.5, and a standard deviation of 4.5. We are looking at confidence level of 95% as a decimal, that is 0.95. Then we can see our usual t-interval calculations. So we have our base estimate or our point estimate, which is just our sample mean minus 1 minus our sample mean 2. The standard error is calculated for us. The degrees of freedom is calculated for us. And then the critical value, the t sub c, is found, as well as our margin of error. And then the interval itself, we have a lower limit of 2.96 and an upper limit of 8.43. So I'm going to take a couple quick pictures of these. All right, and now I'm going to transfer those over to our notes. All right, so this is all of the information that we pulled out. So in order to find our confidence intervals, we need to have our base estimate for the sort of the center of our interval. So this would have been, when we do our interval, we put 5.7 in the middle. This is our difference in sample means, 18.2 minus 12.5. Then we have our standard error and our T sub C. And to find margin of error, we do T sub C times our standard error or standard deviation of the sampling distribution. And then we take that standard error, or sorry, we take our margin of error and we add it and subtract it to get our interval. So we'd add that 2.73, subtract that 2.73. I'm just showing you sort of what was going on in the background of all of these calculations. And that should land us precisely on our 2.96 or 2.967 and our 8.432. So our interval itself, we have, this is the left end and the right end of our interval. So our interval, we are looking at about 2.96 to say 8.43. So the whole goal of this was to estimate the difference in the average hours of work a week between CSU students and UC students. And we did 1 minus 2, so we did CSU minus UC. So since we're doing CSU minus UC, and we got positive values, that means that CSU should be higher, right? So if we subtract numbers and get a positive result, the first number is the larger one, right? So since this is positive, that would mean that CSU is higher. If it were negative, UC would be higher. And then if we are both negative and positive, so if it were negative 2.96 to positive 8.43, then it's a little harder to interpret because it could be that CSU is above or it could be UC is above, depending where the actual value falls. But for our final interpretation, writing our conclusion, we have I am blank % confident that blank falls between blank and blank. We are going to do the very generic sentence first, and then we'll write it in a format that maybe would make more sense to people not familiar with statistics. So I am 95% confident that the difference in the average hours of work a week between CSU students and the UC students falls between, what do we have, 2.96 and 8.43 in overload hours. And this is not the most straightforward sentence. What we're looking at is we're estimating that on average, CSU students work between 2.96 and 8.43 more hours than UC students. So So we are estimating that the average hours of work a week of CSU students is between 2.96 and 8.43 hours more than the average of UC students. Again, we know the average is more or higher than because we had a positive difference. The interpretation of that 95% confidence, the method we used to select our sample and find the confidence interval is expected to yield an accurate result. (95% of the time). So this is maybe a way that we could explain in just slightly more layman's terms instead of that generic confidence interval concluding sentence. But this is a way to sort of describe our results and how much we should trust those results. All right, so that is a 2-sample T interval.